Hi, we're Team 5. I'm Sasha.
I'm Amin.
I'm Emilio.
Frank.
And our project is the LAMP module. Our customer is Alex Gorsuch from Magpie Innovations, which is the company that owns the FieldMAK, which contains the LAMP module.
So the objective of our project is to miniaturize the electronic components of a pre-existing LAMP module to make it both more affordable and portable.
The LAMP module is an electronic device designed to heat chemical reagents for testing in third world countries. Our primary targets are low-income customers.
And this is our project for New Mexico State University's EE300 Cornerstone Design.
This is an overview of our hardware design. It's split up into two main parts. The first part contains the custom PCB that we made, which is where the users can interact with the LAMP module. The board also has Bluetooth capabilities, which will allow the connection to the mobile app that the user can use. The second part is the heating chamber, where the thermal sensor and nichrome wire is located to heat up the substances to facilitate the chemical reaction.
This diagram represents the logic of the Arduino programming we use to run the LAMP module. As you can see, once the program initializes it, it figures out through user input whether it will operate the heating chamber with the default time and temperature values, or user inputted values sent over Bluetooth. The program ends once the heating process is over.
We began assembling our board on Tuesday, November 27th. Overall, the process was quite simple, with our only initial problem being receiving the wrong LED bar. The most challenging part was soldering the micro USB, as our board didn't have any mounting holes for it. This eventually caused the port to come off, forcing us to resolder it.
After our board was assembled, it came time to test all of its components. In the beginning, you can see us flipping between the Bluetooth and default modes of the device by pressing the onboard buttons. After the start button is pressed in the default mode, our device begins sending current through the MOSFET. You can see our LED bar indicator filling up as time progresses. After the device has completed the heating cycle, the LED bar indicator and RGB LED begin flashing to indicate to the user that the cycle is complete. In this short clip, we show how our device can communicate over Bluetooth with an Android phone.
I had soldered before taking this class, but I've never soldered electronic components. And I've learned quite a few new soldering methods from Mackie, the TA of this class.
Another takeaway from this design is the use of latex to make reports. Not only did we have to figure out how to work the code in latex, but we also had to figure out how to make a professional formal report.
And then a lot of us had never used Eagle for making boards and layouts, so that was the first for all of us, and we learned a lot about designing things to be manufactured.
It was also our first time using Bluetooth pairing, coding the Bluetooth, so learning the syntax for that, and also just the pairing functionality in general. That was also a good experience and a nice learning curve. The major challenge of this project was that our team took a pivot at the beginning of the semester. We started out with one project and kind of had already done the interview process for that and started developing ideas for it. And then we had to change to a different project, redo the interview completely, and start a new thought process design for that. And so that was a major turning point that we had to overcome.
Another challenge we faced is our parts didn't come in until later into the semester. So we had to do assembly and testing very close to the deadline.